Hey there, Chargers, it's Mrs. Boyd. Today we're talking about secants and tangents and their arcs and angles that intersect in and on the circle. So we know what tangents are. We know a tangent intersects our circle at one and only one point and is perpendicular to the radius. We know a secant goes through the circle and doesn't have, oh, there's a complaining dog. So it's just a line that goes through our circle. We want to know how we can measure arcs and angles when we have these secants and tangents that intersect on the circle. We have a secant and a tangent, and they intersect where the tangent intersects with the circle. So what can we do? We want to know the measure of angle AEB. How can I find that? It is equal to half the measure of angle of arc ADE, which is known as the intercepted, complaining dog, arc. So we intersect the arc at this point and this point, right? D just tells us that that part of the arc is within the angle that we care about. All right, so the measure of the angle is half the arc. That feels a little like we've talked about it before. Wink, wink, wink. Let's put this to good use. We have a real similar looking circle, and I want to know x. I want to know the measure of x. If my angle measure is 110, remember, the measure of the angle is equal to half the measure of the arc. We can say 110 is half of x. So to get x alone, we just multiply both sides by 2, and I get x is 220. Similarly, I have the angle measure or the arc measure, and I want to know the angle. Well, the measure of Rosa. The angle x is half the arc. So x is half of 280. That means x is 140. Angle measure. Keep it going. Now I'm looking at the other side of my angle, and my intercepted arc is going to change. I'm looking at AEC now. I have the measure of BEA, but I want to know the arc on the opposite side. So what we're going to do is we're going to find the measure of arc AED, and we can do that by saying the measure of the angle is half the measure of the arc. Let's call this y. So then we multiply both sides by 2, and we get y is 230. Well, the entire circle is x plus y. So to find x, I do 360 minus 230. And that gives me that x is 130. Similarly, I'm going to look at the opposite angle x on the right here. I'm going to call this angle y again, and I know that the measure of the angle is half the intercepted arc, half 272. That means angle y is going to be 136. I know BC is a line, so that if I add x and y together, I should get 180. They should be supplementary. So x is 180 minus 136, or 44. All right, straightforward. So far, so good. Flip your paper over, and we're going to look at arcs, secants, and tangents that intersect inside the circle. This is a little bit different. You can see we've got two secants We're not going to have a tangent that intersects inside the circle because it doesn't go inside the circle. But we're going to have these two secants. They intersect inside the circle. If we want to find the measure of angle AED, that's this angle here, we need to say it's equal to half arc AD, which is here, plus arc BC, which is over here. Let's give these some words. AD is the intercepted arc. It's the arc that is formed by the angle that we care about. Arc BC is the arc from the congruent vertical angle. You can see AED and BEC are vertical angles. They're formed by the same two lines. They make an X. That tells us that angle AED and angle BEC are congruent. They're the same. So to find the measure of that angle, we have to take half the sum of the two arcs that make up those angles. Let's try it out. We have another circle here. We want to know X. So to find the measure of the angle X, we're going to say that is equal to half the two arcs that go along with those angles, 80 plus 40. That means X is half of 120 or 60. Likewise, I want to know X on the circle on the right. I'm going to do the same thing we did on the other side. I'm going to find the angle that I know I can find, and then we're going to use that to get X. Angle Y I can find, that's 1/2 the sum of 160 and 50. That means Y is 1/2 of 210. That tells us Y is 105. To find X, AC is a straight line, so X and Y are supplementary. So X is going to be 180 minus 105. That means X is 75. Few more here. Same idea, but this time we want to know the arc, and we're given one of the angles. We're just going to plug in what we know. We know this angle is equal to half the arc, the intercepted arc, which is X, and the arc from the congruent vertical angle, which is 38. Well, I'm going to multiply by 2 and get rid of this 1/2. I'm going to multiply by that reciprocal, which is 2 over 1. So 140 is X plus 38. I can subtract 38 from each side, and I get X is 102. Last circle to the side here, we've got X is an arc, and we don't know the angle. So this one is really straightforward. We're going to find this angle first. And we're going to, because DB is a straight line, that means this angle here and 94 are supplementary. So we'll say 180 minus 94 is that angle we need, and that's 86 right there. So to find arc X, we'll use angle is 1/2 arc plus the arc from the congruent vertical angle. We're going to multiply by 2 again. That gives us 172 is X plus 58. And we subtract 58 from each side, and we get X is 114. Pretty straightforward. Let's do some more. I'm going to add the other 2 notes onto here about the secants and tangents that intersect outside the circle. We put those on here. Be right back. All right, top of this page, we're gonna knock these out real quick. Secants and tangents outside the circle. 3 different cases. They're all gonna work the same. Don't despair. We have secant and secant intersecting outside the circle here at point A. One secant, another secant. They intersect. We want to know the measure of the angle. Well, you might have guessed it's going to start with a 1/2. And we're going to take 1/2 times the measure of arc DE minus the measure of arc BC. Arc DE is the outer arc, is what we're going to call it, on the outside of the circle, furthest away from the vertex. How about that? And measure of arc BC is the inner arc. I missed the word arc here. So BC is the inner arc closest to the vertex. Shortest arc closest to the vertex. All of these are going to be outer minus inner, no matter what we're looking at. Secant and tangent. So we have one secant and one tangent. Measure of angle A, we want to know. It's going to be 1/2 the measure of arc BED minus the measure of arc BC. That is BED, we can think of as the outer arc, furthest from the vertex, and BC is the inner arc, outside minus inside. Last but not least, tangent and tangent. One tangent here, another tangent here. They intersect at A. We want to know the measure of angle A. We find that by doing 1/2 times the measure of arc BEC minus the measure of arc BC. BEC is that outer arc. BC is the inner arc. All right, now that we know all those specifics, let's do some problems. First, we want to find angle A. Well, the measure of angle A is going to equal, didn't leave myself enough room there. Let's scoot over a little bit. Measure of angle A is, it was no better, 1/2 outer, furthest from the vertex is 90, minus inner arc, 30. That means the measure of angle A is 1/2 of 60, otherwise known as 30. Let's find X on the next problem. We want to know the inner arc. That means the measure of angle A, we know, is 30. That's going to equal 1/2 the outer arc, 105, minus the inner arc, X. Again, I'm going to get rid of that 1/2 first and make it times 2/1. That's 60 equals 105 minus X. I'm going to subtract that 105 from each side and get X alone. That means negative X is equal to negative 45. You could just think, switch both signs if you want. You can also imagine there's an imaginary -1 in front of the X, and we have to divide both sides by it. That means X will be 45. The inner arc will be 45. Measure of angle A is what we want now. Same thing is going to apply. Measure of angle A is going to be equal to, well, this is a little bit different. We don't know the outer arc, but we do know all of the rest of the arcs of the circle. So we can say 360 minus 110 minus 40 is going to be the arc that we're missing. That arc is going to be 210. So now we know angle A is 1/2 the outer arc, 210, minus the inner arc, 40. So angle A is 1/2 of 170. That means angle A is 85. Next one, we want this outer arc again. Or I guess we haven't found the outer, we found the inner arc. Measure of angle A is 60, and that's going to equal 1/2 the outer arc minus the inner arc. Multiply by that reciprocal of 1/2 again. That's 120 is x minus 80. I can add 80 to each side, and x is 200. Last few problems. We want to know angle A. Well, I know the inner arc, but not the outer arc. But the inner arc and the outer arc are the entire circle. So 360 minus 120 will give us the outer arc, which is 240. So the measure of angle A is 1/2 outer arc minus inner arc. That means angle A is 1/2 of 120. Angle A is 60. Last problem. We want to know x. I know one angle and not the other. You might be saying to yourself, what are we going to do? Well, we're going to say x is the outer arc. That means the inner arc is everything else. It's 360 minus x. Let's plug this into what we know. The measure of the angle is 70, and that equals 1/2 outer arc minus inner arc, 360 minus x. I'm going to get rid of the 1/2 first and make it 140 is x. Now I'm going to distribute this -1 in front of the 360 minus x. So it becomes x minus 360 plus x. Combine like terms on the right. 140 is 2x minus 360. I'm going to add that 360 to each side. And that gives me 500 equals 2x. I can divide by 2, and x is 250. All right, I hope this makes all the sense to you. I hope you are following right along and ready to close out the trimester. Let me know if I can do anything for you, and I'll see you real soon.